Hello everyone, and thank you for watching this presentation. I am Kyropoulou with HKS Architects and the University of Houston. The paper titled Weather File Creation for Remote Underserved Locations addresses the unequal distribution of weather data across the world, starting with the challenges related to climate analysis and building performance for a new neonatal unit design in Mbale, a remote small town in Uganda in Eastern Africa. This paper suggests a methodology for creating hourly typical year weather files using reanalysis data calibrated using short-term on-site measurements. In the end, it suggests that use of this methodology can be applicable in any location under certain conditions. On a worldwide level, there is a great discrepancy between different parts of the globe in relation to the number of weather datasets available. Although coverage was improved after the 70s, there are still severe gaps observed in Africa. Understanding the localities of the project included, of course, the climate and its effect on building design. The Köppen-Geiger classification indicates an AM tropical monsoon climate, but how could we go beyond climate classification? One of the biggest challenges to understand the nuances of the climate and perform building analysis was the inexistence of measured weather data and lack of a reliable typical year weather file, often called a TMY file. The closest weather station was found roughly 50 kilometers south of Mbale in Tororo. Besides the reported climate differences between the two locations, the quality also of the Tororo weather data was very poor. Without knowing yet what was possible or not, we started our collaboration with Joe Huang of White Box Technologies, who later agreed to be the co-author of this paper to discuss the potential of installing our own weather station to record data on site. There have been some efforts to overcome scarcity of historical data in Africa and many other parts of the world. These include interpolation of observations from existing stations, as well as the use of proxies such as satellite rainfall estimates and climate model reanalysis products. Reanalysis refers to the use of large weather forecasting computer models in a retrospective mode to estimate weather conditions anywhere in the world for the past 20 to 30 years. There are also reports of a hybrid approach where station observations are combined with satellite data for rainfall and reanalysis data for temperature. Previous experiences have found that while good in capturing weather conditions, general conditions, reanalysis data are limited by the imperfections and granularity of the climate forecast models. While atmospheric modelers have used techniques such as downscaling with mesoscale climate models, this project worked with the National Oceanic and Atmospheric Administration known as NOAA's MERA-2, which stands for Modern Era Retrospective Analysis for Research and Applications. With NOAA's MERA-2 reanalysis data, and used a simpler method of calibrating the MERA-2 data with the local weather station data. The advantage of this simpler method is that the calibration implicitly adjusts for all differences between the grid cell and the actual site. Furthermore, by calibrating the weather parameters, the absolute accuracy of the climate modeling becomes kind of secondary. The main unknown factor of this method is whether a calibration done for one period will extend to a different, longer period. How consistent and repeatable are the differences between actual measurements and the reanalysis data over the year? The selected weather station for the application is a wireless solar-powered model. Although the core team is based in the US, the weather station was purchased from Europe due to data transfer frequencies reciprocity with Uganda. Local doctors then download data periodically and supply the design team in the US. The installation and data collection related decisions were made relative to the specifics and challenges of the location and the site, proximity to the console, unobstructed landscape, and of course security were the biggest priorities. The weather station began recording data in February 2019. The obtained field summary data collected for roughly half the year are then combined with satellite data on solar radiation to create partial weather files equal in length to the obtained measurements. The created file is then compared to meteorological reanalysis data and used to calibrate them and to produce a functioning TMY weather file. Since the measured data were initially half year of length, the rest of the year was generated using the calibrated reanalysis data to go back in time for 12 years and find the most typical conditions that would complement the file. Previous work by my co-author Joe Huang had found that the differences between actual measurements and reanalysis data were best described as differences in average hourly profile by month. Since Mbale is very close to the equator, the differences in average daily temperature profiles do not change much, even between different months. Because the calibration profiles could only be calculated for February through June, it was decided to use an averaged annual dry bulb correction profile for the missing months, while a single annual dew point temperature correction profile was used for all times. For wind speed, a simple multiplier was used to reduce the MERA2 wind speeds to match those at the on-site weather station. This typical year weather file then is used to analyze the climatic conditions and also assess the performance of the building. The authors and the design team, with the help of the local doctors and hospital maintenance team, managed to successfully install and operate the first weather station in the city of Mbale in Uganda. Proper maintenance of the weather station will allow for this data pool to grow, and it will be used for readjustment purposes in the future. Calibration of reanalysis models using only summary data that cover most of the climate variations with focus on the rainy and dry season produced a reliable weather file of sufficient accuracy for design purposes. This was mostly possible since the climate variations during the year are minimal in a location right at the equator. The methodology of calibrating reanalysis data using summary measured data can be applied in other locations as well. Attention, though, must be paid on the proper installation of the weather station and the seasonal climate variations. Thank you very much.